Here we are again with a pre-calc lesson. This one's 25. We will have age and rate problems. This one is all word problems. I've already written them out. You can take time to write them out. These have a bunch of different patterns that we are going to fall into. The best way to do them is by example, though. So let's talk about age problems. 10 years ago, Thomas was twice as old as Patricia. 5 years from now, Thomas will be 10 years older than Patricia. How old are both people now? So I'm going to have T be Thomas's age and P be Patricia's age. Okay, and I first start with 10 years ago. So if T is Tom's age now, let me specify that, it's right now, present, 10 years ago would be T minus 10. So 10 years ago, Thomas was means equal sign, twice as old as Patricia. So 2 times Patricia, 10 years ago, right, is Patricia minus 10. Now our next equation, 5 years from now, so Thomas in 5 years is T plus 5, will be 10 years older than Patricia. So Thomas in 5 years will be 10 years older than Patricia. 10 years older than Patricia in 5 years is P plus 5. Now we have a system of 2 equations, 2 unknowns. Okay, I'm first going to distribute everything. So I get T minus 10 equals 2P minus 20. And T plus 5 equals P plus 15. Okay. Now, doesn't matter if you solve by substitution or elimination. I'm going to solve by substitution, so I'm going to add 10 over. So T equals 2P minus 10. And I'm going to substitute that in here. So I have 2P minus 10 plus 5 equals P plus 15. So then 2P minus 5 equals P plus 15. I'm going to subtract P, and I'm going to add 5. So I get P is 20. So Patricia is 20 years old. Now I take that and plug it in here. So T is 2 times 20 minus 10. So T is 40 minus 10. So Thomas is 30 years old. Now be careful. It says how old are both people now? It will often ask you things like how old will Thomas be in 20 years? You would take this, because Thomas is 30 now, and add 20 to it. Okay, these are our age problems. All the age problems will fall into the same pattern. Now, let's talk about rate problems. For rate problems, we remember our equation distance equals rate times time. It's going to be the foundation of all we do in these problems. We'll have a couple problems that will vary slightly. Okay, let's look at this problem. Joe Frank can wash 3 cars in 5 hours, and Merle can wash 4 cars in 3 hours. 15 cars need to be washed. If Joe Frank works for 2 hours and is then joined by Merle, how long will it take them to wash 15 cars? So when we have 2 people doing an activity, the distance equals rate times time equation expands because we have 2 rates. So we still have distance, but it will equal the rate of Joe times time plus the rate of Merle times time. Okay, now distance is rate times time, so rate is distance over time. In this case, distance is the cars washed, and time is still time. So the rate of Joe Frank, he can wash 3 cars in 5 hours. So his rate is 3 cars per 5 hours. The rate of Merle can wash 4 cars in 3 hours. Now 15 cars need to be washed. That's going to be my distance. So I'll have the rate of Joe Frank times time plus the rate of Merle times time. Now it's the same time because they're working together. They don't each have their individual time. And this is going to wash 15 cars. Now, Joe Frank works for 2 hours and then is joined by Merle. So our distance is 15 minus the work that Joe Frank does. Well, Joe Frank worked for 2 hours at a rate of 3 cars per 5 hours. Okay? So, what I do here is I want to add these together, right? Because I want to simplify. Okay. Now, what I could also do is I could multiply everything by 15 to get rid of my common denominator, 5 and 3. It doesn't matter. So, in your trusty calculators, we're going to do 3 divided by 5 plus 4 divided by 3. And math, enter, enter, make it a fraction. So I'll have 29 over 15t equals, then I have 15 minus 2 times 3 over 5. Again, make it a fraction. And that gives me 69 over 5. And I'm going to multiply both sides by the reciprocal, 15 over 29. So this cancels, and I get t equals 69 over 5 times 15 over 29. Gives me 207 over 29, and time is in hours. It doesn't matter that you get a fraction, okay? You can work a fraction of an hour, right? You can have a portion of an hour that you're working. So remember, if you have 2 people working together to do something, it is their distance equals their rate times time plus rate times time, right? The rate of one person times time, the same time for both, plus the rate of the other person. And if one person works a distance ahead, right, we subtract that distance from the total distance that we want, which in this case, our distance is cars washed. All right, let's do another example. Maya can empty 2 bottles in 3 hours. Working with Wilbur, she found they can empty 4 bottles in 3 hours. What was Wilbur's rate of emptying bottles? Again, so this is going to be distance equals the rate of Maya times time plus the rate of Wilbur times time. Now it tells me that the rate of Maya is 2 bottles in 3 hours. So this is bottles per hour. We don't know the rate of Wilbur. That's what we're looking for. We know that their time together is 3 hours and their distance was 4 bottles. So now we plug everything in. Distance is 4 equals the rate of Maya times their time, which is 3, plus the rate of Wilbur, that's what we're solving for, times the time of 3. And now I solve for my rate of Wilbur. My 3's cancel here, so I have 4 minus 2, which gives me 2 equals 3 RW. Divide by 3, so the rate of Wilbur is 2 over 3 bottles per hour, which is actually the same as the rate of Maya. How nice. Don't forget, you need to label your units. Bottles per hour. Bottles. Okay? This does count for points. You do have to label your units. Again, we had 2 workers working for a distance. So a distance equals the rate of one times time plus the rate of the other times time. It will start to fall into the same type of patterns. Let's look at a different type though. Okay. If 5 workers can do 1 job in 8 days, how many workers would it take to do 3 jobs in 7 days? Now in this case, if we have workers doing something, our equation is rate times workers times time equals jobs. Okay, now I don't know my rate, I need to solve for it. So rate times, I have 5 workers, they can do 1 job and it takes them 8 days. So my initial rate is 1 over 40, which is jobs per workers days. Then it says, how many workers would it take? So I use the same rate, 1 over 40 times workers, I don't know what my workers is, to do 3 jobs in 7 days. So I'm going to multiply everything by 40 and divide by 7. Right, and this ends up giving me 53 times 40 divided by 7. Gives me my workers is 17.14 workers. Now, we know that that's a bit ridiculous because we can't have a fraction of workers. So we would say it takes 18 workers. You always round up when you're talking about people. But nonetheless, this is the answer that the book will probably show you, is this decimal, even though we know you can't have a portion of people, or we hope you don't have a portion of people, okay? Whenever you have a problem, that is workers, rate, doing a job, rate times workers times time equals jobs. Before, we had distance equals rate of one times time plus the rate of the other times time. Now we have rate times workers times time equals job. Okay? All right, let's do another example. Mary had 252 gallons of milk. This would feed 42 infants for 12 days. Okay? This is actually very similar to rate times workers times time equals jobs. Now we have rate times infants times time equals milk. So again, we need to find our rate times, we have 42 infants, 12 days, and 252 gallons of milk. So my rate is 252 divided by 42 times 12, which gives me 1 gallon per 2 infant days is my rate. Then I want to know 14 more infants were added. So I use my rate 1 over 2 times I have 14 more, which means I add 14 to 42, giving me 56 infants were placed in the nursery. I want to know how long will the milk last, so I'm looking for time. And 48 more gallons were provided, which means I have 252 plus 48, which is 300. So again, I'm going to multiply everything by 2 and divide by 56. So what I get T is 300 over 56, which is about 10.71 days. Again, don't forget your units. You need to have units for every one of these problems. They're word problems. They have units. They have units in the question. Again, if you have a rate, workers, this case infants, times time equal job, this is the equation you use. Okay, you need to start to recognize these patterns because we're going to use these for a lot of problems in pre-calc. But for now, those are all the examples we have, so good luck on the rest of your homework.